Jai Hind. Today we are going to discuss about continuous charge distribution. Here the charges are uniformly distributed in a definite region. It is called a continuous charge distribution. There are of three types. Number one, linear charge distribution. Here the charges are uniformly distributed on a definite length or a road. It is one dimensional, and now we can define what is linear charge density. For example, this is a conductor and the charges are uniformly distributed on the surface of the conductor. We can assume that. Let dq be the charges in a small length dl. Now linear charge density is given by lambda equals charge by length. That is, dq charges are distributed in the length dl, and hence lambda equals dq divided by dl, and its SI unit is coulomb per meter. Then number 2 is surface charge distribution. Here the charges are distributed in definite area. It is two dimensional. 2D means two dimensional. For example, consider a thin sheet of plain sheet, and here the charges are uniformly distributed on the surface of the plain sheet. Consider a small area ds, and here dq charges are there. Then surface charge density is given by sigma is equal to charge divided by area. And charge is dq distributed in a small area ds, therefore sigma is equal to dq divided by ds, and its SI unit is coulomb per meter square. Third one is volume or cubical charge distribution. It is three dimensional, and here now we can define what is volume charge density. If charges are uniformly distributed on the surface of the volume, for example this is a sphere, and if the charges are distributed on the surface of the sphere, we can consider a small volume dV where dq charges are there. Now volume charge density rho is given by the formula charge divided by volume, and it is rho equals dq by dV. SI unit is coulomb per meter cube, and all the three quantities are scalar in nature. So this is a very easy topic, and just by heart the formula for linear charge density, surface charge density and volume charge density. Now we pass on to another important topic, that is Gauss's law. Gauss's law states that the total electric flux through a closed surface is equal to that 1 by epsilon 0 times the charge enclosed by the surface. Total electric flux through a closed surface is equal to 1 by epsilon 0. Epsilon 0 we know it is permittivity of free space. 1 by epsilon 0 times the charge enclosed by the surface. And we can write the mathematical expression as total electric flux. We can write phi equal to E dot S. The formula for electric flux is E dot S equal to, we can write integral E dot ds. If ds is a small area, then we can write the total electric flux is integral E dot ds equal to, according to Gauss's theorem, it is 1 by epsilon 0 times the charge. This is called Gauss's law. Total electric flux is equal to 1 by epsilon 0 times the charge enclosed. Hope you understand what is uniform charge distribution and the Gauss's law, statement of Gauss's law.